Inside your microwave oven, we can see the power transformer. The danger sign is there to scare you. Cut out the secondary coil using a vibrating saw. The secondary core has a lot of wire windings. Replace the core with less windings of high current wire. This is the spot welder I made. The copper electrodes press down with the material in between to weld. Make up a circuit to control the time that the spot welder turns on. These are components from old downlights and microwaves. We use some experimenter's circuit board. Mount the components to the board. Work out the layout so that it flows. Drill the board to fit the relays, etc. I arranged power in and out on one side. The other side has a push button and a capacitor terminal. The microwave relay has upper and lower outputs. The upper outputs are removed. Under the board, the wiring is fairly neat. The exposed terminals of the black relay will be sealed off. We use a 12-volt DC plug pack. The capacitor is chosen by trial and error. Here I test the relay circuit. The push button terminal is connected. The capacitor charges. When the button is released, the black relay clicks. The pulse of light shows how fast the welding pulse will be. The pulse can be changed by changing the value of the capacitor. To make the welding probe, we use thick wire. The actual electrodes need to be thick and strong. I will try this 3mm brass brazing rod. We cut two 5cm lengths. Jam the rods into the thick wire. Hold securely in a vise. We set the soldering iron at a high heat. Solder the copper and brass with a lot of solder. We're not sure if brass is the best material, but that's what I had. Copper rods may be better to not stick as much to the welding material. We'll see that later. I bent the rods so they are close together. We use some SR Ivalon dental acrylic. We mix it up and press it around and it sets pretty quickly. This can be added to itself and it sticks. We can sand and drill it too. I made a push button that will be bonded with more yellow stuff. We're doing a probe test here. My test bench is made of Caesar stone. We don't want this transformer sticking out, so we squeeze it in a vise and break off the case. We cut up some old exit signage. We glue the components to the signage plastic. This test shows the 100 microfarad capacitor was too small and it didn't even set off the welder, so we swapped it to a 470. This increased the time as the capacitor is larger. We remove the copper welding arms. Join the new spot welder probes. The probes connect to the circuitry neatly placed inside. The push button controls the weld time. Here's the first practice welding. It's a bit sticky. So why do we want this welder? Here's a snap-on rattle gun I bought for 90 bucks with a non-working battery. The replacement cells are $99, so we open up the pack and test to see which cells are okay. We found that only 3 were faulty. We gently break off the connections from the faulty cells. The cells have been spot welded at the factory. If you're careful, you can re-weld the same connectors. If you break the tabs off completely, you can buy nickel strips. Here's a $10 fake Makita battery that I bought. It's rated at 14.4 volts but reads 15.8. It's rated at 3 amp hours but the cell's at 2000 milliamp hours, so something dodgy there. We transplanted the cells with the welder. This is snap-on rattle gun, saved for $10. Thanks for watching.